So, welcome once again to our Disruptive Innovation Festival talk from here at Metabolic HQ in Amsterdam. And today we're talking about revolution. We're going to start a revolution with your help, hopefully. And today we're specifically talking about why the circular economy needs an information revolution. So a bit about us to start with. Metabolic, we're a consulting and venture building company that uses systems thinking specifically to tackle global major sustainability challenges. Our founding mission is to transition the global economy to a fundamentally sustainable, and that means circular in our eyes, state. So we work with governmental organizations, businesses, non-profits around the world on some of these ideas, not just ideas though, but also sort of developing, building and actioning some of these things into practical, visible and scalable solutions. So why this topic specifically? Well, we've been around for 5 years. We've learned a few things about the circular economy. And we've noticed, or we believe very strongly, that to make the transition towards the circular economy, the way that data itself is captured, evaluated, and acted upon really does need to change. So we believe we need nothing short of a global public utility to manage information. And today in this talk, we're joined by our founder and CEO, Eva Gladek, who's going to be breaking this idea down for us, going to be unpacking the idea of the global public utility and the information revolution, identifying and providing solutions perhaps for some of the challenges that will stand in our way, but also laying a lot of the context around the data revolution and why we believe this is such a fundamental tool that we need to address. So just to introduce Eva and maybe embarrass her a little bit as well, Eva, originally from New York, came over to Amsterdam, set up Metabolic in 2012, and I tried to do some maths, but I did actually lose count because I'm not very good at multiplication. But I think you've probably advised or worked with over 300 companies and industry leaders in the past 5 years. Sectors ranging from electronics to agriculture and all sorts of things. And in the past 3 years, you've been named amongst the Netherlands' top sustainability influencers as well. So, and I think that is recognition of not only the ideas, but also this revolutionary spirit, which we're going to look forward to hearing a bit more about today. So without any further ado, I'll pass over to Eva to talk us through the revolution.
Thanks, Adam. Great introduction. So, as Adam already said, what we're talking about today is why the circular economy needs an information revolution. We believe that data is actually the next frontier that we need to pass through as practitioners in the circular economy. And I'm going to explain to you guys a little bit why we think that's the case and how you can potentially get involved. So to start with, probably everyone who's watching this is already fully aware of the fact that we are facing a sustainability crisis as a human civilization. Since the 1950s, we've been in the middle of what has been called the Great Acceleration. So if you look at these various graphs of basically resource use and pollution of different kinds over the extent of human history, you see that in around 1950 they start to go up very rapidly at a scale that is suddenly relevant to what's going on our planet, to the actual functioning of different planetary systems. So we're in the middle of this great acceleration, and a lot of people are particularly concerned with climate change, and of course with good reason. But actually, if we look at all of the different planetary systems that are under strain right now, there are many others than the climate system that are actually even more severely transgressed. For example, biodiversity. According to WWF, we have lost around 58% of global biodiversity in the last 40 years. And if we're talking about exponential growth and doubling cycles, that means that we have around 20 years to really figure out how to stem this tide of ecological destruction, or we will end up with pretty much no biodiversity left on our planet. Likewise, nitrogen cycles and phosphorus cycles, these are essential nutrients that are used in agriculture. Most people don't normally think about their importance to the functioning of the biosphere as a whole, but right now we're putting over 2 times the amount of nitrogen into the planet's ecosystem than is naturally deposited from the atmosphere through nitrogen fixation processes. And this is having widespread effects on how the planet is functioning. So all of these things are being driven by a growth in population, a growth in economic activity that comes with that growth in population. We're consuming and producing more, and these activities of ours are creating these stresses that are having all this myriad of effects on the planetary system. And we absolutely need to figure out how to change the way that we're working. We need to change the way that we're producing goods, services, the way that we're consuming, and the way that we're dealing with products at the end of their lives, basically putting them back into cycles in a useful fashion, retaining the high value of those different products. And that's what the circular economy is all about. Now, one of the big theories that is put forward by politicians around the world, as well as different governing bodies like the United Nations, is something called eco-economic decoupling. What that means is that people have this idea that we should continue to be able to grow the economy while reducing the amount of impact that's caused for every euro or dollar that we're earning or that we're creating in the economy. So this is the kind of holy grail. And a lot of people have talked about the fact that we need a factor 10 at least reduction of impact per euro in this kind of eco-economic decoupling model. So that's a great idea, and it's something that we absolutely need to achieve. And in fact, the circular economy has been used as a framework for achieving eco-economic decoupling. So a lot of people see it that way, that we can continue making money, basically, while reducing all the impact associated with the processes that typically allow us to earn that money. But there is a bit of a catch here, and that is that right now, we can see from the results that eco-economic decoupling is still not really working, despite all the investment that we're putting into redesigning products, investing in green energy, etc. And we're achieving some results, certainly, but for the most part, what you can see is that we're achieving relative decoupling. So that means that for every euro that we're earning, we're producing slightly less impact or damage, but overall, we're still increasing in that impact and damage because of the exponential growth of our population and our demands for different resources. So what this means is that we have to fundamentally take a look at this system and redesign how it's functioning, and really have different approaches for producing products and goods that are going to actually fit within a planet that has a population of 10 billion or 11 billion people by the end of this century. So, in short, we really need exponential solutions to tackle the exponential problems that we're creating. And that's a very different mindset, and it's a very different approach to design that we need to take with a lot of our products and supply chains in order to achieve that. So why are we failing so far at achieving the levels of environmental impact reduction that we need to achieve to keep our planet habitable? Well, one of the really important reasons is that we have the wrong tools right now. So I'm going to focus on one of these in particular, and that is life cycle assessment, or LCA. Many of you have probably heard of life cycle assessment. This is basically the leading state-of-the-art approach that's now used to evaluate the environmental impact of products and services across their life cycles. And this is also used to give the manufacturers of products and their designers feedback on how to improve the environmental footprint of a product or service. And the way life cycle assessment works, so imagine that I'm going to do a life cycle assessment on this cup, for example. I would basically map out all of the different processes across the entire supply chain of this product that led to its creation. So that would start all the way back at the mining of silica and the transport of that silica and processing of that into glass and then forming this cup, etc. And you can define what scope you want to include within the life cycle of this product. So you can say, well, actually, I want to look as far back as the manufacturing of the machines that were needed to mine the glass, the silica to produce the glass, etc. And that's basically the scope of the life cycle. Likewise, you can also look at the downstream side. So what happens to this glass after it breaks and I throw it out? And how is that going to create impact in the environment if it's landfilled or burned? Now, the thing that you do when you're conducting a life cycle assessment is that for each of the steps along the supply chain that led to the manufacturing, use, and disposal of this product, you map out the different types of impacts that were created at that step. So you look at all the different resources that were consumed, so all the inputs of that step, and you also look at all the pollution and impacts on the environment that were caused as a result of those actions. So you create an inventory, what's called the life cycle inventory, along each of those steps in the chain. And then you add together all of those impacts in a single pile, basically, for that product. So what you end up with is a kind of report card where it says, okay, well, this glass, in its manufacturing, it consumed this many non-renewable resources, it produced this much CO2, it used this much water, etc. Now, this seems, on the face of it, like a really good technique. It helps us understand how many resources were used for a glass relative to this couch, etc., so we can start to compare which ones are more or less impactful. But unfortunately, the life cycle assessment methodology is missing a lot of key components to really understand the impact that a glass like this or any sort of product has in its creation and use. And to illustrate that point, I can give you a couple of examples. So let's say it took 1 cubic meter of water to manufacture this glass. Well, it actually matters a great deal where that water was extracted. So was it in the middle of a desert region that already has a lot of water scarcity, or was it in the middle of a rainforest where there's a lot of water available? And how many of these glasses were produced? If it was millions, well, then that impact gets multiplied by the amount needed per glass. And you also need to know whether that's happening in a region where the water scarcity can handle that kind of increase in amount of water demand. So context is really essential. You need to understand where and when the impact is happening in order for it to even be meaningful. Likewise, California recently went through a very long drought. These types of water extractive impacts are more important to deal with during a drought than when there isn't a drought. There are also lots of natural cycles that you need to take into account. For example, migration periods, where if you have lots of lights up during a construction project, you can have a very serious effect on the local populations of birds or bats, whereas you wouldn't normally in other parts of the year. So these types of contextual issues are really critical for properly evaluating whether or not something has an impact. Another thing that I mentioned at the start of this talk is the planetary boundaries. And that leads me to a second point of failure in life cycle assessment. And that is that it gives very little feedback about the absolute budgets that we have to work with in terms of impact. So one of the questions is, well, when I said that this glass used a cubic meter of water in its manufacturing process, the question would be, well, is that a lot or a little? Is that okay? We actually need to know, we need to have better feedback for designers, for companies as a whole, as to whether the amount of resources that they're using to deliver a certain product or service, whether those are reasonable amounts of impact to cause for that product or service. And the only way that we can do that is if we can connect the supply chains and the product-based impacts to the actual limits of what our planet can handle. Another tricky thing about this, and it relates to the context issue that I just mentioned, is that these impacts are these limits, these boundaries that we have to deal with, are very contextually dependent. So greenhouse gas emissions, or those things that are causing climate change, are probably one of the only impacts that are context independent. It doesn't really matter whether you fly a plane here in the Netherlands or drive a car in the United States. The carbon dioxide emissions that you're putting out into the atmosphere are going to be the same, and they're going to distribute equally throughout the atmosphere and have the same effect everywhere in the world. But if you're talking about land use or biodiversity or erosion of soil or all sorts of other effects, all of these are really important to look at within the context of the local region and local ecosystem where they're occurring. A final thing that is really important is that we have to have much better ways of understanding trade-offs. One of the things that happens, so if you're a designer and you do this life cycle assessment, you see where all these different impacts are occurring across the life cycle of your product and the supply chain that it likely has. You have to make certain choices about whether to prioritize avoiding impact 1, maybe water use in a particular area, or impact 2, biodiversity loss in another area. And we need to be able to understand which of these is more important. And there are always, every single product casts a shadow. There's no such thing as a product or service that will not have some kind of environmental impact. So it's important for us to be informed as designers, as consumers, and as organizations, which of these impacts we need to prioritize avoiding. And the only way that we can make a proper decision about that is if we understand the two other things I just mentioned: the context in which these impacts are happening and the absolute boundaries and tipping points that we need to be avoiding when looking at these impacts. So, where does this leave us? We basically need a completely different way of approaching product design, and we need this solution to be affordable and accessible to the millions of people who are now becoming designers and producers of their own products through things like the makers movement. We want to encourage people to be able to conceptualize and produce their own products for their own local needs and use upcoming tools like 3D printers or collaborate in smaller groups with artists to develop really locally specific solutions and express their creativity. But it's even very difficult for large companies with huge amounts of money and resources to apply even life cycle assessment to current design principles, or to current design processes, rather. So the solution that we need is something that will allow us to understand all of these contextual issues, these absolute limits, bring that information instantly to the fingertips of designers and manufacturers, and do it in a way that's affordable and accessible and easy to understand. And that might sound like a tall order, because it is. But it's something that we've determined through all of our research that it is absolutely essential for us to develop such a set of tools that will make this possible, or we will not be able to achieve the goals of decoupling our economy from the impact that it's having in the time that we have to solve these challenges. So that's why this is an invitation to a revolution, and it's something that we need a lot of people to join us on. So if you consider a living organism, like me or like the plant here that's on this table, all living organisms have ingenious systems within their bodies that are basically sensors. They're constantly monitoring the state of your blood chemistry, the temperature that you're at, your position. All sorts of information is continuously being collected and fed back through your hormones and through your nervous system to make sure that your body is in homeostasis and that everything is functioning well. And as our economy has evolved into this meta-organism, what we actually need is to have all of these different sensors throughout what the economy is doing, feeding back into some kind of central system of oversight so that we understand how to continue staying within homeostasis as a planet. And that's kind of what the system that we need for optimizing sustainability decision-making and design has to look like. What we're envisioning, in short, is a kind of virtual Earth platform where we have all of the different data about the way that the planet currently functions, so about rainfall and soil conditions and land use and biodiversity levels in different areas, all stacked together in a kind of data sandwich on a virtual Earth representation. And a lot of this data already exists. We have satellites that are continuously revolving around the planet, collecting this kind of information. There's really amazing projects looking at forest cover and how it's changing live. There's all sorts of weather monitoring, etc. So all of this information is already out there. We believe that what we need to create collectively as a human civilization is a centralized civic data utility that takes all of the information that we have on the functioning of the planet, on the different ecosystems, on the different soils, water areas, weather patterns, etc., and bring that together in a public data bank that is easily accessible and can be interfaced with different tools that allow for optimized eco-design. The way that this would work is that you have this massive data sandwich of all the different satellite data, sensor data, and open source GIS data available about the planet. And onto that, you can plot supply chains and really see where different impacts are happening that are associated with specific products. And that way we can really start to make decisions about how to optimize those supply chains, how to optimize the selection of materials, and have that be grounded in real-time information on things like droughts, on political situations, on the environmental conditions that are continuously changing. One of the important things about this is that it should ideally be quite dynamic. So if there is a drought in California, you temporarily need, if possible, should shift from sourcing certain products from that drought region to places where it's less impactful. This type of tool, this kind of public digital infrastructure for all of this information would ideally also interface with all sorts of plugins like EcoDesign Tools for specific sectors so that they can optimize the selection of their raw materials and understand which of those raw materials are the least impactful for their given purpose. And I am going to talk a little bit more with Adam about some of the things that we're doing working towards this and some of the things that our partners and other companies that we admire are doing in order to build this kind of digital infrastructure. Another thing that we're going to discuss is what we might actually need in order to make this happen and some of the challenges that we will inevitably face. We're completely aware that this is not going to be easy, but we believe that this is the single most important development that has to take place in order for us to successfully transition the economy to a sustainable model. And that's why we're putting all of our effort behind creating this data infrastructure of the future. And we hope that lots of you out there understand this and would also like to join us in this mission.
Well, Eva, thanks very much for that talk. And for me personally, it's very interesting to kind of get into this subject. I also have the benefit of not really knowing anything about this, so I can hopefully ask you some of the awkward, embarrassing questions that the people back home might be thinking as well. And as you were talking, I was thinking about this idea of revolution, which makes me think of a couple of things. One is the idea that we're challenging something that's urgent, but it's also something that isn't happening, that we really need to shift. So on that first point, I think you just touched on it in your closing comments about this importance. I think a lot of viewers will be thinking about all the kind of competing demands on our attention around sustainable transformation. And you pointed out that this is the single most important thing that we can do. And is that because it kind of unites everything together, that it unlocks the potential of all these other streams of effort that we're working towards in terms of building this circular economy?
Yeah, well, that is one of the reasons that I think it's so important. There are lots of other reasons as well. For one thing, I think we are investing a lot of money, attention, and effort into fixing or making certain products or systems more sustainable in the wrong way. So a lot of the time, if someone takes a product and tries to optimize it, they may improve its energy performance, but create new problems with waste management or with toxicity. This is something we call burden shifting, and it's something that we're looking out for all the time when we advise companies on how to make more sustainable products. And I think this happens a lot because people don't have the full picture. They don't have the insight of where we really need to be focusing our attention, or how we really need to be optimizing products or supply chains. And that's one of these key missing pieces to successfully achieving this transition. So that's one of the big things.
Okay, thank you. And the other point about this revolution idea is that that we need to shift things. You mentioned that we're working on some of these things as well. So perhaps you can tell them people who are watching a little bit about what Metabolic's working on in our way towards this. But also, why is this still a challenge? Why are not more people doing this, or is it just it's happening in pockets of isolation, and this is the tool that really brings everything together?
Yeah, so I mean, I think you do see this movement to connect data to sustainability decision making, and that's emerging in lots of pockets indeed. So there's projects that are tackling it piece by piece. A really interesting example is Provenance, a company that's looking at supply chain data and point of origin information about different products and trying to bring that out to the front. A lot of different supply chain management tools have been bringing in this kind of information as well. And also a lot of eco-design efforts have sprung up that are attempting to tackle these issues. But indeed, it's a lot of scattered efforts, and there isn't really a centralized point where all of these things come together. And another issue is that a lot of the tools and information that's collected are still proprietary. And that's one of the key things that we're trying to advocate against, is to make a lot of this information open. This idea of a public data utility, one of the core elements of that is that it should be information that's held in trust for the public. That and that doesn't mean that everything has to be made open, and that there can't be proprietary business models that draw on this core tooling, but there are some things that really should be made available to larger numbers of people.
Just on that point then, can I ask how we can actually unlock that then? Because I suppose there must be a number of organisations who are sensitive to their data privacy, how the data is used. How can we encourage people to engage with this topic and get them to share this data? How can we actually access it?
Yeah, so there are many answers to that question. So for one thing, a lot of the data that we need is actually public. So there are lots of different public data sets out there that are collected by NASA or by, like, for example, through the satellite program that I mentioned, or different nonprofit organizations, but they're very difficult to access or make sense of. So they're either really old, wonky programs that, you know, put out really difficult to read spreadsheets, or very difficult to navigate. And a lot of the information is split up into different silos. So you have great resources, but just about water, and some about land use, et cetera. So they're not brought together where you can actually see the interrelations between water and land use, et cetera. So that's one challenge, is to bring all this information together under one umbrella where it's easily searchable and accessible. And then, of course, there's all the proprietary data, which is very important. And to answer that, I think it's a little bit like the invention of the telephone. So when the telephone was first invented, if there were only two people who had one, you can imagine it's not very useful. It's like, I can call you and you can call me, and we have this expensive device that just allows us to call each other. The telephone became more and more useful the more people had it. And because that meant that lots of people could call one another. And I think with this kind of public data utility, the more information that ends up in it and the more people are putting into it, the more value and more insight it can generate, because it suddenly has much more rich, fine-grained, and real-time data. And I think that that has to be one of the big incentives to get companies to put in their information, at least to a certain extent, so that in exchange for putting in information about their supply chains and resource extraction, they'll get a lot more insight about the risks that they're potentially facing in certain supply chains, or trends around the availability of certain resources, et cetera. So hopefully there will be a kind of positive momentum.
You mentioned risks there as well. I mean, risks in the supply chain of not engaging in this, but what about the risks of being engaged? I mean, is there a potential that some people could manipulate the data to their own benefit, or for false accounting, or that some people might extract some value from this tool that's beyond the sustainable ambitions of it? So, for example, you could imagine a situation where, for example, an insurance company might look at the data and decide to increase its costs to various customers based on the data that's coming out through the transparency, even if that was misleading them in some way. How can we get across some of these risks?
Yeah, there's definitely some risks in assembling such a tool, and in terms of data being falsified or manipulated, that's always a risk. I think actually one of the things about this type of infrastructure is that the more information you have, the more it can balance itself out and run sort of check calculations to see whether information makes sense. So it can uncover false information in that way. And I think that's one of the important things that has to be done with such a system. So a lot has to be done to even get to the point where we have such a digital infrastructure. We need common data protocols. We need ways of verifying information that's placed into the system, and a lot of this has to be automated. So there's a lot of effort that needs to be put into building and testing such an infrastructure.
Okay, and
I don't know if I answered all of your question.
well, no, you did. And I wanted to go back to a question that I asked earlier as well about kind of what's happening next, the next stages. So we mentioned that Metabolic is actually working on some of this stuff itself, and that's going to be obviously part of a step towards this tool. But tell us a bit more about what that project is, how it works, and then how that is a stepping stone.
Yeah, sure. So obviously it's very difficult to tackle this whole picture head on, and that's not what we would aim to do ourselves. What we've started to do instead is focus on a specific sector, the chemicals sector. And we've designed a software tool called Chem DSS, which is actually an EcoDesign tool for formulated chemical products. So that means any sort of products that are a mixture of chemicals, like a shampoo or a cleaning product. And what Chem DSS does is it has a virtual lab, let's say, where a chemist can mix together ingredients in this virtual flask that they would like to put into their product, and the tool gives a live readout of whether there are better ingredients that can that have the same functional properties that can be swapped out for the ones that are most problematic. And that's on the level of both toxicity to people in the environment as well as environmental footprint, so things like CO2 emissions and water use, etc. So that's the first step within Chem DSS, but the next thing that we want to do is link that up to real supply chain data. So have suppliers, let's say there are many suppliers of basic chemicals like ethanol, which is alcohol. And if all those suppliers are able to put in the information on how much energy was used or water was used to produce that particular chemical and where that was done, so where their manufacturing facilities are, we can automatically calculate the impacts associated with the transport of those materials. And we start to get this contextualized picture of what I was talking about, where you're not just understanding the life cycle inventory or the total footprint of the product, but also the context of where it happened. And we can slowly begin to layer in contextual data. And so the reason we're focusing on one particular sector, on formulated chemical products, because that narrows the amount of information that we need to look at. And we plan on layering in all this contextual information as we go. But once that's done, we can start using that same base layer information for other sectors and for other eco-design tools, for example, for textiles.
So I suppose one of the ideas is that once you've shown people the value of decision support tools and the value that this can create in their organization to accelerate the transition to sustainability, then not only does that unlock the potential of that idea across various sectors, but then that also takes us to the next level of kind of realizing this global utility tool.
Mm-hmm. Exactly. Although for the global utility tool, we really believe that it should be held by a foundation, and because it has to be held in the public trust, as we said. And that means that we don't necessarily want to own that as Metabolic. We want to create an organization that will steward this global data pool. So we're trying to create the first steps to lay the groundwork to illustrate the importance of this kind of tooling, and hopefully be able to generate the momentum with other partners who are interested in creating this larger utility.
So a lot of progress is being made, a lot of exciting developments on the way. If we kind of just spool back a bit, we look at things like Buckminster Fuller calling for something like this in the 1960s. Al Gore was talking about this in the 90s. We've got NASA working on bits and pieces of this. We've got the Society for Digital Earth. So there's people talking about it, there's some action happening, but none of those kind of calls to action or ideas have really manifested themselves in this tool yet, in this transition or revolution. So what makes it possible now to actually make this come true?
Yeah, so that's a great question. Indeed, there has been a lot of even explicit calls for a digital Earth platform over the years. And I think one of the things that has changed now, well, there's a lot of things that have changed. One of them is that the technology has really advanced rapidly, especially in the last 10 years. We now have artificial neural networks. We have a lot more going on in the field of IoT and remote sensing and satellites and satellite imagery. So all of that stuff can be put together, combined with much faster processing speeds. So I think a lot of the technological barriers have been brought down to some extent. But moreover, I think the urgency for what we can do with such a tool is much higher. The world is much more interconnected. We're facing all of these different sustainability challenges, and this really is one of the only ways that we can comprehensively start to address them. So the benefits of creating something like this start outweighing the costs, and that's why I think now is a moment that things like this can really accelerate. And that's what you also see through the different bits and pieces of projects related to this that are emerging. So different supply chain mapping tools and provenance and all these other things that we've mentioned and looked at.
Thank you. So couple of thoughts then. One is a final thing that you'd like people to do if they'd like to kind of find out a bit more about this revolution and engaging in this kind of transition. But then beyond the kind of the work that we're doing, what other things in the world would you like to see that would accelerate this idea? So what changes in the way that in transparency, data capture, etc., can happen beyond this that would help accelerate this idea specifically as well? What can other people do?
Yeah. Well, I think there needs to be a kind of broad commitment to opening up data across different organizations. And a lot of public institutions already have this commitment, but not even all public institutions do. Some cities still keep a lot of data locked up, which would actually be much more beneficial when released to the public. So that kind of general commitment and advocacy within organizations, I think, is important. Another thing is that we really need to sort out data standards. So we need to agree on certain standards for capturing and communicating data, and that's something that does require some more central coordination, and this is something that policymakers should ideally tackle or flag as a really relevant issue and put effort into coordinating protocols for storing, communicating, and transmitting data. And this is already happening to some extent in IoT, so in sensors and devices that are embedded into objects, but ideally this kind of standardization should happen more across the board.
So you talked about policy making then. What role could you see from a kind of a top-down perspective on this? What kind of governmental intervention could really help accelerate this as well? Is this something that we should be looking to be more kind of carrot rather than stick, or how do we get the right balance there?
Yeah, well, I actually think earlier this year we started working with WWF, the Worldwide Fund for Nature, on a project called One Planet Thinking. And that project basically takes the idea of these planetary boundaries and asks the question of, okay, so what budgets do we have for different sectors? And our conclusion, as I just said in my short presentation, is that you can't really ask about budgets for many of these things because they're so regional. So you really need to look at watersheds and ecoregions to evaluate what sort of limits there are. And no one has the authority to, in many cases, no one has the authority to impose these limits. That is actually a political process. So it would be very important for whole regions, whole ecoregions, to come together to define protocols for the boundaries for their particular watersheds and land use and ecoregions, and actually put that into law, into legal effect, to say, okay, well, these are the boundaries that cannot be crossed within the Alpine region or something like that. And once those things are actually put into law, then there need to be mechanisms to verify that we're not crossing those boundaries. So there's actually a lot that has to be done on a political level in recognizing that it's not good enough to just do better than your sector in terms of impacts, or better than you were doing last year. It actually has to be related to real planetary limits, and those have to come from a political position.
Yeah, okay. So how are we going to know that this is working, that we're on track and we're going to deliver this tool? Where are we going to be seeing, if I sat down with you in 2 years' time, what would this tool look like? At what stage would be in the development?
Well, I would like to, in 2 years' time, have a very well-functioning version of Chem DSS that is successfully helping formulated chemical product designers optimize the impact and toxicity of their products very easily, and relate that information to supply chain data. So have a fully working supply chain module. And at the same time, I would like to be at the point where we have launched a foundation that can serve as the hub for the broader kind of digital earth public data utility platform, where we would love to see many other players like the World Resources Institute and WWF and governments, et cetera, participating in defining and shaping what this thing should look like. So that's what I would like in 2 years, and I think that it's doable within that period of time. But I don't think we'll be near done. So okay. I think the proof of concept should be established by that point. Okay, great. Well, we'll check back with you in 2 years just to see how we're getting on with that. In the meantime, if you'd like to keep updated with all the news that's going on here at Metabolic, do check out the website, metabolic.nl, and sign up to our newsletter. We'll keep you updated with all the progress on our Digital Earth Revolution work and Chem DSS. Thanks for joining us at the Disruptive Innovation Festival. Thanks very much, Eva, for walking us through this idea of the digital revolution. And we hope all of you watching at home or wherever you're watching this will join us on this revolution and help us create this tool and lead the transition to the circular economy. Thanks very much.